Okay, so same deal. If we got kicked out by the 40 minutes limit, let's just jump back right away. I know I talked about getting a better Zoom, but I don't know how that will work because there will be several other coaches. Will they be okay to get the same version of Zoom? I don't know. I don't know how that will work. So we're still stuck to this free Zoom, which has 40 minutes limit. Really apologize that. So how is it going with the homework so far? We have 2 meetings. Let me just say thank you for doing the survey and paying the registration fee. And we don't have a lot of coaches to have separate team at this point. So there will be some arrangements for the people that choose the blue. I just say there will be no mandatory requirement for each homework. It's purely for your personal development. But if it's too stressful, totally understand. At this point, we're just trying to get one stable pace for everybody until I see other coaches coming in. This is one of the positions that we can't assign. The coaches need to have some qualification to be a coach, and so it's hard. So we'll keep an eye on it. So homework. I hope you guys learned something in the past 2 meetings. Any feedback? General feeling? Too stressful? Too hard? Okay, while we waiting for that, why don't we start talking about homework right now, and let's see what we got there. Let's see what we have. Let's look at this problem 524. Okay, I can't, my screen just froze.
Just stop sharing and reshare.
Stop share. Okay, one more time. So what do you guys see?
The statistics for the Google form.
Perfect. Okay, so I'm just looking at anything below 60%. Okay, for example, 516. That's worth of talk about, right? So 516. How many positive divisor of 3240? A multiple of 3. Okay, 3240. Okay. Let me stop share for a little bit so that you can see the whiteboard. 3240. So what's the first step?
Prime factor.
Prime factor. Thank you. Let's try with 8. So 4, 0, 5. Sound about right? Try 5, 81. So this is 99, right? So we've got 2 to the 3rd, 3 to the 4th, and 5. Right? 2 to the 3rd is 8. And we got 3 to the 4th, right? And then 5. Okay, how many are multiple of 3? Basically, anything that contains 3 will be a multiple of 3. So what we're seeing is 2 to the 3rd, 3 to the 3rd times 5 times 3, right? So we just take the 3 out. So we're just looking at this part, right? Everybody is still following? Okay, so now we're just looking at how many divisors total, including 1 and itself, does this number have? Can someone tell me the answer?
I think it's 32.
How do you calculate it?
3 plus 1 times 3 plus 1 times 1 plus 1.
Very good. So that's exactly right. This gives us the answer because we just use the exponent plus 1 of each. I think the critical part is you kind of convert the original problem into this, right? We need to take 3 out. So all the divisors in here will times 3 will be a multiple of 3. So you just need to get all the divisors of this part, which is 32. Okay. All right, continue sharing. All right, what's the next one? We're doing not so well. So 517 is also. Okay, this is the same problem. The same number, how many divisors of that are perfect squares? Do you see we've already encountered quite some problems about perfect squares, right? This is a like hot topic of number theory. So the divisors, they like to mix up that with perfect squares. So let's stop a little bit so we can see here. We can start from here. The same number, this is their prime factor. And how many of them is going to be square? So basically, we want to pick one prime factor at least twice, right? To see how many of them you can pick, right?
I think there are 5.
Yeah, you're almost correct, but let's see. So
6?
okay, go ahead. What's 6? Can you start giving some steps here?
Yeah, so 2 to the power of 3, that means 2 to the power of 2 would be 1 square. And then there would be 3 to the power of 2 and 3 to the power of 4. And then 3 times 2 to the power of 2. And 2 times 3, no, wait. I know there's one relating to the 3 to the power of 4, but I don't know what it is.
Okay, what about the 2 times 3 square? And then the square. Right? Because 3 has 4th and it has, you can do the 3 square.
Right, then, that's what I was gonna say.
Yeah, but is that the end of it?
I think there's 1.
There's 1. Don't forget 1. So actually, in a problem like this, write 1 first, okay? Look at if 1 is the answer. Is 1 the answer? Yes. Did I stop sharing?
Yeah, you're not sharing.
Okay, good. Yeah, 1 is not an answer. If 1 is answer, write it immediately and then work on the rest of things, okay? So this is very perfect. So the way to work on this is you start with, you start with a single prime, right? For single prime, you can have 2, 3, and 3 square, 3 possibility, right? This is the 3 things. And then you start with a combination of the 2, in which you can do is 2 times 3, that's definitely 1. And then 2, because 3 has the power of 4, so you can do 2 times 3 to the square. That's another possibility. And then in the end, you have 1, okay? So the answer is 6. here. Okay, every problem I'll allow maybe half a minute question time before I move on. All right, looks good. Now, what else should we look at? Oh, so 524D. So 524, 3200. How many divisors are perfect squares? Okay, so this is, we're just keep stumbling on this square things. Now, anyone volunteer to get through this?
This is
Go ahead.
I can't say the full factorization, but I can like just say the numbers. Like it's 10 times 10 times 4 times 8.
Okay, 32. 32 is 2 to the 5th, right?
Yeah.
And then you have 100. That's 10 by 10, which is 2.
2 to the 7th power times 5 to the second power.
So it's 2 to the 7th, 5 to second. So that's a very good first step. If you get this step wrong, then no hope to get it right for the rest of it. Okay, so how many perfect squares are we talking about here? How do we start this? Okay, we're gonna start from the only contain one prime factor. So we're gonna have 2 to the square, and 2 to the third, right?
And 5 also.
Yes, then 2 is, and then 5. Okay, this is a 4. Now, how about combination here? So,
2 times 5.
2 times 5, that's the first one. And then
2 to the second, 2 power 2 times 5.
okay, so let's keep 5 and we keep increasing the 2's, okay? And then we can do 2 to the third times 5, right?
And 1.
Is it done?
No, 1.
Is it 1? So that's the correct answer. So the answer is 8. Okay. Now, what else are we looking at here? And E, so it's still the same problem. This is exactly the same problem I spoke in the meeting, right? Difference is we use the example of 5400, and I expect higher accuracy on this one actually. Now, how many positive divisors are not multiple of any perfect squares other than 1? So any volunteer? Okay, well, let me stop share. Okay, so this is the same problem. So let's just wipe this out. So not multiple of square. We just did multiple of square, right? So that's we can pick at least twice of one prime factor. So for not multiple, we just pick only once on each prime factor. So when it's only have one prime factor, we can have 2 and 5, right? Come on, we've been through this before, right? So 2 and 5, and if it's a combination, it's gonna be
1.
Combination of 2. Okay,
10 and 1.
yes. Okay, let's write down 1 because 1 is a valid answer. And then when we do the combination of the two, there's only one, which is 2 times 5. That's the valid answer. Anything else, you have to either multiply by 2 or multiply by 5, which become a perfect square. Okay, so the answer is 4. Okay, but the thing is, no matter how hard it is, I think majority of people get the correct answer. So that's something. 535, what we got here. Okay, this one I will go through here because this is a little bit tricky. Read this problem if you forgot. So m and n are positive integer. They're GCD. Okay, sometimes they use GCD, sometimes they use GCF. So you just need to know D means divisor. So greatest common divisor, or largest common divisor. So it's the same meaning. Okay, so the GCD has 5 divisors and LCM has 30. So what is the greatest possible number of prime divisors that n could have? All right, I'm going to go directly jump to this. So GCD is m. GCD has 5 divisors. So odd number of divisors. So we immediately conclude this must be some kind of integer with power 4, right? So that's the only possibility. And if the LCM, well, anybody got this part? 5 divisors.
Sense now because 3
Okay, so
it makes sense now because 9 has 5 and 9 squared is 3 to the power 4.
Yes. Yeah, that's a good example. If it's looking at 81, that's 3 to the 4th, right? That has 5 divisor. Any odd number of divisor, it must be some kind of a square. And specifically for 5, there's no other way can make 5. You know, something times something equals 5. So there's no other way other than 4 plus 1 times 1, right? So this has to be a prime factor of 4. Okay. I mean, we have been through this a lot of times, so I'm gonna make this really quick. Okay. Now LCM has 30. So 30. So what we think about 30. So LCM. So we want to know what's the maximum possible of the n, right? It means, how about LCM is the maximum of m would be LCM is him itself, right? But if LCM equals to m, that's the maximum we can get, right? So can m have 30? If you have 30 divisors, 30 can be 5 times 6, right? And this 5 comes from here because you know, when you have something in common, then this will still remain in the LCM. So this 5 doesn't change. The question is, how do we construct 6, right? So if you just say, okay, what about some prime order of 5th, okay? Then you have this K4 times P5, right? If m equals to this, then 4 plus 1 is 5, 5 plus 1 is 6. So this will give you 30 divisor. But I only have 2 prime divisors, right? This is not great. But what if I put the 6 as 2 times 3? Okay, if I put 2 times 3, then I can say, okay, then m can be the k4 still remain the same. I can be a1 times b2, right? So this gives me 5 times 2 times 3 equals 30. And fortunately, this is our final answer because there's not much choice when you look at 6, right? So at most, M will have 3 prime divisors. Okay, this problem is a little bit tricky, has a lot of concept involved. So take a little more time offline, get a good digestion about that.
How is the answer 3 again?
Yes, answer is 3. Are you asking how is answer 3?
Yeah.
Okay. So which part of this steps are you missing here?
I got the part like k to the power of 4, a to the power of 1, and then b to the power of 2. I just don't get how you got 3.
Oh, if m is equal to, if m's prime factorization is, let's say k, a, b are 3 primes, and if you can write m in this way, then do you know how to get divisor, total divisor, number of divisor of m?
Yeah, I would add 1 to each of the exponents and then multiply them.
Yeah, so that's 4 plus 1 times 1 plus 1 times 2 plus 1, right? So this is 5 times 2 times 3. So that's 30. Except what we are working backward, we're working backwards because 30 is 5 times 6. And then we put 6 into 2 and 3. And then we're kind of working backwards to feed in here. Do you get it?
Yeah, okay, thank you.
Yeah, okay. Good question. So we will be probably kicked out very soon. I got some reminder message in here, so don't forget to dial in back. Okay. I think we are doing pretty well in the rest of problem. Let's see. Oh, 42. 42. Okay. 42 is a little bit tricky, but I want to remind you about modular here. Remember what I always emphasize, modular property about exponents on both sides, and it still hold. Okay. If you forget, make sure you review this. Yeah, I feel like I'll be kicked out very soon, anytime now. But let's do this. So this should be pretty straightforward if I start. All right, so 10 to the power of 10s. If you look at this, we want to say 10 to the power 10s. We want to look at 7, right? So basically that's the mod 7, because we want to divide 7 to look at remainder, right? So, but we want to see what 10 to the mod of 7. How does that do? So we know 10 with the mod of 7, that's the remainder is 3, right? So we know it's congruent to 3 mod 7. And because of that property, we can do the exponent on both sides, right? So this congruence still hold. Now we want to do a little bit more transformation on the right side, because the 3 to the 10th is still too big. What about 3 to the 10th equals 9 to the 5th, right? Can everybody got that? Or if we can write this way, 3 to the 10 is 3 to the square 5th, okay?
But why would we want to do that?
Yeah, because I'm going to tell you, okay? So this is 9 to the 5th. So because 3 and mod 7, there's not much we can do, but 9 with mod 7, it actually gave me another remainder, so which gives us more newer information, right? So what we rewrite is congruent to 9 to the 5th mod 7, right? So we still don't know what this will do, but we know 9 congruent to 2 mod 7, right? Therefore, 9 to the 5th will congruent to 2 to the 5th mod 7, okay? And this is something we can calculate, and this is 32 mod 7. And 32 mod 7 is what? If we look at remainder,
4.
4. 32 divided by 7 is 4, remainder 4, okay? So this is around here, okay? Basically 4 mod 7, okay? 4. Okay, just to take half a minute. So we start from here. 10 is congruent to 3, so we do the power 10, and then we transform 3 to the 10 to 9 to the 5, and 9 to the 5 is congruent to 2 to the 5, and which is congruent to 32, and 32 mod 7 is 4 mod 7. So you just write in here, okay? So this is our first term, 10 to the 10th, okay? Now, when we talk about the second term, 10 to the hundreds, that is basically 10 to the 10th to the 10th, right? So if you look at, we already know 10 to the 10th, look at this, 10 to the 10th, I write here. 10 to the 10th is congruent to 4 mod 7. So this whole thing, we can just do another 10th, right? This should still hold, right? So this is going to be 4 to the 10th mod 7. Very similar. 4 to the 10th is too big, but we want to see 4 square to the 5th, which is 16 to the 5th. Does that give us new information? Yes, because 16 to mod 7 would be congruent to 2. So this become 16 fifths mod 7. And 16 mod 7 would be congruent to what?
2.
2, right? Because 16 divided by 7 is 2, 14, 2. So remainder is 2. So this becomes 2 to the 5th mod 7. Bingo, 2 to the 5th is 32. So this is same. Remember